So like I was saying, we're talking about solving linear inequalities. And last week we talked about solving linear equations. And the process for how you solve a linear inequality does not differ from solving a linear equation. Okay, the main difference that you're going to see is that instead of an equal sign, you're going to have a greater than or less than sign. Okay, and I can show you what those look like. They are, let me pull it up. I need that up. I need this. I need this. So your one-step inequalities, we're dealing with less than and greater than. Okay, so the equal sign has effectively been removed, but the process for how you share or how you solve these is the exact same. The little intricacy that you got to expect is when we are dealing with multiplying or dividing by a negative number. In that situation, in a linear equation, there's no issue. We just handle it like we normally would, and we carry out the division and all of that good stuff. But in this world, it's going to cause us to flip the sign, and you'll see that from the equality property of multiplication. Why are you not? Oh, so it didn't click. Okay. So your added vocabulary is set builder notation. And what set builder notation is, it allows you to identify items that make your statement true very quickly and easily. The way you handle it is that you would not nominate your set a given variable. It could be X. And then you list out the proper requirements or requirements for being in set X, which would be your actual inequality once it's solved. Okay, and we're also going to be using a number line. So those are pretty simple, pretty easy. And we'll talk about the little intricacies there. Okay, so our first key concept should be on page 11 of the PDF if you're using that way, or you should be able to see it on the screen. It says, for any real numbers, A, B, and C, if A is greater than B, then A plus C should be greater than B plus C. Okay, and it can get kind of complex when you're dealing with math and you're dealing with actual words and sentences rather than just numbers. I know that's one of the main complaints I hear about algebra, is that math was easy when it was just numbers, but as soon as they incorporated variables, it's when it got difficult. But if you just think about this logically, so if we were to nominate 5 as A, fill in 5 as A, and say we have B as 2, and we're going to say that C is 1. In order to prove this, and to make sure that it's proved, that I have 5 is equal to A, B is equal to 2, and C is equal to 1, what that statement is saying is that it should be true that A plus C, or 5 plus 1, is greater than B plus C, or 2 plus 1. So we know 5 plus 1 is equal to 6, right? Simple math, very easy, very simple. 2 plus 1 is equal to 3. So in order for it to be a true statement, we would have 6 is greater than 3, which everybody knows. We learned that way back in elementary school. Just gets a little difficult when we're dealing with the actual units. Okay? And then it also says that if A is less than C, or if A is less than B, then A plus C should be less than B plus C. Okay, so they work the same way, taking the information that you've already known and applying it. Okay, and that's what your addition property of inequality is. And they do a good job of illustrating it on the number line. So if you look here, A is to the right of B, so it is clearly larger. We have C units. So once we're adding, we're always moving to the right. Therefore, A plus C, the end result, should be greater than B plus C. Okay, now the subtraction property of inequality. For any real numbers, A, B, and C, if A is greater than B, then A minus C should be greater than B minus C. Okay, and we can use those same exact numbers. So again, we have a number line here. A is farther to the right, so it is greater than B. If we take away C units, you can see that A minus C falls to the right on the number line from B minus C. Okay, and then if A is less than B, then A minus C should be less than B minus C. Okay, so A is to the left on the second example of the subtraction property of inequality. B is right here, so B is farther to the right. We take away C units from each, and you can see that A minus C falls farther to the left than B minus C. Okay, and the issue that some people might encounter is they don't quite understand how a number line works. Hopefully this is straight review for you guys, and I'll get rid of the shared screen here in a second. Okay, so what I've just drawn is an example of a number line starting at 0. As you can see, your numbers increase as you move farther to the right, with 0 being the midpoint. So if I move from 0, 1 unit to the right, I'm at 1, another unit's 2, another unit's 3, another unit's 4, another unit's 5, all the way until we hit positive infinity. Infinity being the greatest number that we can possibly imagine. Okay, but if we start from 0 and we work to the left, we know that we are going to hit -1 first, -2, -3, -4, -5, and so on until we hit a negative infinity. Negative infinity being the absolute lowest possible number that we can imagine. So we're going to be solving our inequalities, and we're going to be graphing them on the number line. The key thing to remember is as you move to the right, you're increasing, and as you move to the left, you're decreasing. Okay, and we'll be shading in values to show which values make each inequality true. Perfect. Share my screen, get back to that, hit that. Okay, so this brings us to our first example. And it says solve an inequality by using addition or subtraction. They give us solve 4y minus 3, which is less than 5y minus 2, and we're going to graph the solution on a number line. So what I'm doing is just writing down my equation so that I'm able to work with it. Five y plus 2, and we want to graph it on a number line. Back and forth is going to kill me. My back's higher. So we have this. The key thing when we're solving an inequality, the same way that we solved an equation, we want to isolate the variable. We want the variable on one side by itself, not associated with an addition and a subtraction, a multiplication at any given level. Okay? And in this way, there's two ways to solve it, and you're going to get the same exact answer. We could move the 4y to this side and move plus 2 to this side just by reversing our operation that's given. We could move 5y to this side and the plus -3 to this side just by reversing the operation. The beautiful thing is, when it comes to an addition and subtraction, you're going to get the same answer each time. Okay, I'm one of those ones. I like to work with a positive variable associated with it. So I'm going to try to move 4y to this side and bring my positive 2 to that side. So the first step, you can see that this is a positive 4y. Okay, to remove it and get it to the other side, I'm going to minus 4y on each side. What I'm going to be left with is a negative 3 is less than 5y minus 4y is just y, and then I have plus 2. Okay, so I'm starting to isolate my variable. I've cleared out anything that's multiplied with it. Now it's just 1. The second step is I'm going to take this plus 2. I'm going to reverse the operation. So I'm going to minus 2 on both sides. And I'm going to be left with negative 5 is less than y. Okay? Or y is greater than negative 5. Like I said, there's multiple ways to solve it, but a tip that you can do to help graph yourself, or that to help graph, is if we switch this and we have it where y is greater than negative 5. Okay, understand that negative 5 is less than y is equivalent to y is greater than negative 5. The reason and the only reason that we would switch it so that we have the variable on the left is because this inequality sign, being greater than, gives us a tip to where and how we need to graph this. Okay, it doesn't necessarily do it if the variable's on the right side. Okay, but you have multiple operations on how to solve it. It's just a matter of making it work for you. Okay, so I have y is greater than negative 5. So I'm going to draw my number line. Put negative 5 right there. As I move farther to the right, my numbers should be increasing. So from negative 5 going to the right, it goes to negative 4, and then negative 3. As I move from negative 5 to the left, my numbers are decreasing. So I go to negative 6 and the negative 7. And now it's time to graph. Okay, and you can see that my inequality is just saying greater than. What this sign represents on a number line is I'm going to have an open circle on negative 5, and then I'm going to shade everything that is greater than negative 5. So my graph is going to look like this. The reason that we put an open circle is because our inequality sign is greater than and not greater than or equal to. You will see that on the next one. So I believe that y is greater than negative 5. That should be my answer. And here is the book's method of solving. Once again, there's multiple ways to skin a cat. So I got to click on it. First thing that they do is the original inequality. They subtracted 4y from both sides just like we did. Okay, so now they have negative 3 is less than y plus 2. They simplified their like terms that way. Okay, then they subtracted 2 from each side, and they are left with negative 5 is less than y. Okay, and they want you to rewrite it with the y first. Like I said, that gives you a little directional arrow about which way to shade. So you can see our inequality sign is greater than. So any real number greater than negative 5 is a solution of this inequality, as we just proved. And a circle means that this point is not included within the solution set. Okay? And a simple, easy way to check yourself is we've already found out that our solution has to be greater than negative 5. What we can do is we can plug in any variable or any number that is greater than or any number that is less than and actually check ourselves. So I have y has to be greater than negative 5. What happens if I were to actually plug in negative 5? So 4 times negative 5 minus 3 is less than 5 times negative 4 plus 2. take care of my order of operations first. 4 times negative 5 is negative 20 minus 3. 5 times negative 4 is negative 20 plus 2. And now when I simplify, negative 20 minus 3 is going to give me a negative 23. My sign did not change. And negative 20 plus 2 is equal to a negative 18. Okay? And you can check that. That's why it's the basis. Okay, so don't ever be afraid to plug stuff back into your inequalities to double check yourselves. God, I hate having to re-click on PowerPoint. Okay, so here we have a multiple choice. It says, which graph represents the solution to 6x minus 2 is less than 5x plus 7. So once again, I'm going to write my original inequality down. And I'm going to proceed to solve it. Once again, by just isolating my variable on one side. So the first step is pick which side I'm going to have my variable on. This one, since I have a positive 6x and a positive 5x, I'm going to bring this 5x over this side and this minus 2 over this side. First step, I minus 5x from both sides. Now I'm left with x minus 2 is less than 7. Okay, so now to remove minus 2 from this side and bring it to this side, I plus 2 to each side. I'm left that x needs to be less than 7. If I compare it to my number line options, because that's what we're dealing with, I'm going to find the one that has an open circle. Oh, I messed that up. I messed it up again. A simple one. Should be x is less than 9. God, one of these times I'll be varsity bridge for you guys, I promise. Simple mistakes drive me nuts. Dang it. Okay. So to correct my error, I'll show you what I had to do. I forgot to add 2 to 7. Is what I did right here. So 7 plus 2 is 9. Rather than just 7, I apologize for that. So now we're back, and now we're trying to find a number line that has an open circle on 9 with it being shaded to the left because x is less than 9. So looking from our answer options, that should correspond to letter A. Okay, here the multiplication property of inequalities and the division properties of inequalities is where the only differences between solving linear equations and linear inequalities are. Okay, so looking at the multiplication property of inequality first, says for any real numbers a, b, and c, where c is positive. Okay, that's a key thing, where c is positive. Says if a is greater than b, then a times c should be greater than b times c. Okay, and if a is less than b, then a times c should be less than b times c. Okay, the difference occurs when c is negative. Okay, so if a is greater than b, when c is negative, then ac is less than bc. Okay, and if a is less than b, then when we multiply a negative c value to it, then ac is greater than bc. To put that into layman's terms and really make it simplified, whenever you are multiplying both sides by a negative value, we flip the inequality. Okay, you flip the inequality sign. That is also true for the division property of inequality. Okay, so you can see on the examples here where we have 12 is greater than negative 7, which is true. So this one follows if A is greater than B. So, but once we multiply a negative, you can see that on the left side, we get a negative 48, where on the right side, our two negatives cancel out and we end up with a positive. So in order to make that true, we had to flip the inequality sign. Okay, anytime we're multiplying or dividing by a negative number, we flip the inequality sign. Okay, looking at the division property of inequality. It says for any real numbers a, b, and c, where c is positive, if a is greater than b, then a divided by c will be greater than b divided by c. And you can see the example here, where we have negative 12 is less than negative 8. We've decided to both divide those by a positive 4, and we get a negative 3 is less than negative 2, which is true. Okay, you notice how we didn't have to flip the sign. That's because we divided by a positive number. We only flip the sign if it's negative. So when c is negative, if a is greater than b, then a divided by c is less than b divided by c. Okay, and you can see that on the example to the right. So here we have a negative 21. That's an incorrect statement to begin with. Okay, this first inequality sign here should be flipped to make it true. Negative 21 is not greater than negative 14. So negative 21 is less than negative 14 would be true. We divide both by negative 7. And then you can see in order to keep it as a true statement, we have to flip the inequality sign. That one, this top one on this example is incorrect. But it is a true statement once you get down here. Okay, example 2, it says solve an inequality using multiplication or division. We're to solve 12 is greater than or equal to negative 0.3p. And they want us to graph the solution set on the number line. So first up, write down your inequality. The original one, the way it appears, that way you can keep your mind straight. So we have 12 greater than or equal to a negative 0.3p. Okay, this one's pretty simple because it's just a one step. So we're working with it here. In order to isolate my variable, all I need to do is divide by negative 0.3 on both sides, and I will have my answer. Okay, so I divide by a negative 0.3 on both sides. That turns this into a negative 40. Since I divided by a negative number, I have to flip my inequality sign. So my solution to my inequality is negative 40 is less than or equal to p. Okay, with the key thing being always remember to draw or to flip your inequality sign. Sorry, I almost got away with it. I didn't graph it. So once again, I draw my number line. Put negative 40 here. Negative 41. Negative 39. And it says that P is greater than. So since it is greater than, I'm going to have a closed dot on negative 40 because it encompasses it. And then I'm going to shade to the right. Okay, once again, to make your graphing part easier, here I graphed it and I left the variable on the right. If I were to rewrite it with the variable on the left, my inequality sign turns into an arrow and it shows me which way to shade. One of these days I'll figure it out. So they rewrite the original inequality. They divide both sides by negative 0.3, and you can see it reverses the inequality symbol. So they come up with negative 40 is less than or equal to P. Then they rewrite it with P first so that the inequality sign turns into an arrow on which way to graph. And then you can see on their number line, they have a closed dot on negative 40, and they've shaded to the right. So when you're dealing with inequalities, especially when it comes to graphing, you're graphing the area on the number line that makes it true. So once we're done, if we were to plug in a negative 39 in for P into our solved inequality, it would state that negative 39 is greater than or equal to negative 40, which is a true statement. If we were to, and that's why negative 39 is shaded. If we were to plug in negative 41 in for P, it would state that negative 41 is greater than or equal to negative 40, which is a false statement. That's why negative 41 isn't shaded. So we're focusing on shading what makes our solved inequality true. Let's get to an actual hard one. Okay. So here we have what is the solution to a negative 3x is greater than or equal to 21. Once again, all we would have to do here is just divide both sides by negative 3 to isolate our variable. So negative 3x is greater than or equal to 21. We divide both sides by negative 3. On the left side, we would just be left with x. We'd have to flip our inequality sign to show that x needs to be less than or equal to a negative 7 to make that true. So now we pick out our number line graph, since we're dealing with graphs here, and we want to find a closed dot on negative 7 with it being shaded to the left. So that should correspond to answer B. And we got it right. Okay. Now we're looking at solving multi-step inequalities. Once again, it's the same process as solving a multi-step equation. Just the way that it's presented, it looks a little bit intimidating, but in the grand scheme of things, it's really not. Okay, so we have a negative x is greater than x minus 7 divided by 2. Okay, so the first thing, no, I didn't share it to you. So we have that. It's all right, you saw me write it. So the first thing that I want to do is I want to get rid of x minus 7 being divided by 2. So in order to do that, all I have to do is reverse the application that's being done. So I'm going to multiply both sides by 2. On the left, I'm going to be left with negative 2x is greater than x minus 7. Okay, so now here, I still have to isolate my variables. Okay, so I'm going to do that, and I'm going to move this x over here. So I'm going to minus x on both sides. 2x minus x gives me a negative 3x, which is greater than a negative 7. And then to finish it off and completely isolate my variable, I have to divide both sides by negative 3. So I'm going to be left with x is less than a positive 7/3. Okay, so when I divided by negative 3, it left me with just x, caused me to flip my sign. On this side, a negative divided by a negative yields a positive. So I should have x is less than 7/3. And when I'm graphing this, I would not have a closed circle. I would have an open circle because it is just greater than and not greater than or equal to. It's or less than and not less than or equal to. So once again, we write the original inequality. We multiply both sides by 2. They subtract a negative x or subtract x from both sides. And they divide both sides by -3, reverses the inequality sign, and turns our -7 into a +7/3. There's our solution set, and this is what our graph should look like. Okay, you can see the open circle on 7/3 and shading to the left. Okay, so on this one, it says what is the solution to -2x is greater than x plus 5 divided by 3? Once again, we just carry out our steps to isolate the variable. They're the exact same as solving a linear equation, except for when we divide or multiply by a negative number. Okay, so first step, I want to get rid of this divided by 3. So I'm going to multiply both sides by 3. On the left, I'm going to have a -6x is greater than x plus 5. Okay, now I want to move this variable to this side. Since it's a positive, I just subtract -x on both sides. Gives me a -7x. It's greater than 5. And then to finish it off and completely isolate my variable, since it's -7 times x, I divide both sides by -7. And I'm left with x is less than a -5/7. So on the graphs that are right there, I want to find one that has an open circle on -5/7 and that is shaded to the left, which looks like it should correspond to letter B. And we're done. Okay. Here what we have is we were given a word problem, and we need to actually write the inequality and then save the inequality. So it says Javier has at most $15 to spend today. He buys a bag of pretzels and a bottle of juice for $2.59. If gasoline at this store costs $3.39 per gallon, how many gallons of gasoline to the nearest tenth of a gallon can Javier buy for his car? Okay, so here we have a couple variable costs and we have a flat cost. The flat cost that we have first is 2.59. And what I mean by a flat cost is it doesn't matter how many gallons of gas Javier buys, he still spent $2.59 on the pretzels and a bottle of juice. Okay, so that cost isn't fluctuating. You call it a flat cost, a fixed cost, or the constant. The one thing that does vary is how many gallons he can get. So for every gallon, he is going to pay 3.39. Okay, and I'm going to associate a G that represents for gallons. And all of this must be less than or equal to 15, because that's the amount of money that he started with. Okay, so it says let G equal the number of gallons of gasoline Javier buys. The total cost of the gasoline is 3.39 G, meaning we're going to pay $3.39 for every gallon. The cost of the pretzels and the juice must be less than, added to that, must be less than $15. So they planned it out, and we've written an inequality. Cost of pretzels plus the juice is 2.59. Add that to the total cost of the gasoline, has to be less than or equal to $15. Okay, and now we can proceed to solve it. So the first thing that we would do is start to isolate the variable. So we want to move 2.59 from the left side to the right side by subtracting 2.59 on both sides. then we're left with 3.39G has to be less than or equal to $12.41. So what this represents is that he can get as many gallons as he wants as long as he doesn't spend over $12.41. Right? So we want to figure out exactly how many gallons he can get. So what we would do is divide by 3.39 on both sides to completely isolate the variable. Since we're dividing by a positive, we don't have to flip the sign. And since G has to be less than or equal to $3.660 gallons, that's the most amount of gas that he can have without going into debt, okay, or without not being able to pay for it. So a real world issue, a real world situation, and then we can plot it on a number line. All right. And that's what I have for you. And we're not going to go over this last one because I want you guys to have a little bit of time to work on the homework. I think you guys will have about roughly 11 minutes. We'll probably save that question for a bell work problem on, oh man, might be next Wednesday.